is a great agenda for you. First of all, we'll start with a welcome, and that will be from me. So you see my avatar down the bottom. We're then going to look at OpenFaaS logs that have come into the API and CLI, and that's going to be shown to you by Vivek and the next avatar, and then followed by Lucas Rosler, who's going to show you the Loki tool and how OpenFaaS can work with Loki to get logs and a kind of new version of storage that was announced at KubeCon. Following on from that, Matthias is going to show us Linkerd2 and traffic shifting. I don't know if we've got anyone from Buoyant here. If we have, you're very welcome. So we'll see traffic shifting, which is how you can do a progressive release of a new version of your function, and mutual TLS, which will encrypt your traffic all the way from your Ingress controller to your function, through the gateway and back again. Then the chap with the sunglasses is Carlos, and he's going to show something cutting edge. There's a new architecture called Risc-V, or Risc-V, I'm not sure how you say that. I'm sure Carlos will explain it to us. And basically, he's got a small board about the size of your hand, and he's running OpenFaaS on that with Kubernetes. He's been spending the last so many months trying to port all kinds of software to it. He's doing a great job of that. And then finally, to finish off, we've got Andre from Germany in, I think, Frankfurt, and he's going to be showing us OpenFaaS on Power. Power is a kind of IBM machine that's now been opened up to even more vendors, and you can get around 1 terabyte of RAM. And I don't know about you, but I think that's probably a lot of functions. So have we got everybody who's presenting today? Have a quick look. I think we do. Okay, so we'll get on with the welcome. So there's some great news. There's a whole new set of swag available for summer 2019. I'd like to know, maybe you can share in the chat if any of this takes your eye. We've got a hoodie. This is a Bella canvas, a nice lightweight one, good for an air-conditioned conference or an office. And then a light jacket, fleece jacket with the OpenFaaS logo on it. And finally, the regular t-shirt like what I'm wearing here, but with a blue background. So all of these are available to order through the eBay store that I have set up, and they're fulfilled through a company called Printful. Depending on where you are and where the stock is, it will either be shipped to you from the USA or shipped to you from the EU. So if you want to order something, go to the OpenFaaS media repo and you'll get all the instructions there. There's a new thing that you guys should be trying called Function Ingress. This only works on Kubernetes. There's a link at the bottom. And this allows you to get a free TLS certificate and a custom domain for any one of your functions. What could you do with that? Well, let's say you deployed a function that resized images. You could have resize.mycompany.com. Right, and that's something that before you would always have that specific OpenFaaS URL, and maybe you'd have to go off and create your own Ingress records. This does everything for you. We've had a few people try it out already, and there's a brand new blog that you can try. The other thing that you shouldn't miss out on is becoming an OpenFaaS insider. An OpenFaaS insider gets regular insider updates. Here's a few samples, a few teasers if you like. And this is directly from me. And what it is updates on Kubernetes for the week, anything interesting about Raspberry Pi, OpenFaaS, inlets, direct any of the open source work I'm doing, blogs and videos as well. Any money that you use to sponsor to become an insider, it literally starts at $5 a month, which is less than a price of coffee, I believe, goes towards the running costs of the project and means that we can continue to develop it. So a quick roundup on OpenFaaS for anybody that's not familiar with it. This project started in 2016, and we've now been going almost 3 years. The mission of the project in the community is to make serverless functions simple. And through that, we're trying to make a great developer experience. You'll see that in some of the demos today, where we have a great CLI, UI, and API, but also all the things you'd expect, like a Helm chart and the ability to get up and running very quickly. Also, on the operator side of things, want to make sure that your team in your company that vets things going into clusters is going to be okay with it. We've got least access here, least privilege. We've done a lot of work around improving security and tightening things up, including an OIDC provider for authentication, if that's useful to your company. And then we're community centric, and you can tell that by the 31 people that are on the call today. So glad to have you here. Now, if anybody hasn't used OpenFaaS, you can go off and try the workshop. This is something we run as a training. Normally it's a paid training, but you can get access to it for free and work through it at your own pace. So attraction at the moment, we're looking at around 1,600 people on Slack, and that's going up every day. 18,000 GitHub stars. And then something that I'm really proud of is over 220 people have contributed a PR and had it merged. And that number's going up. So if anybody wants to get involved with contributing and you haven't yet, just let us know and we'll try and help you through your first commit. So when we look at what we're doing in this project, one of the things that this kind of the genesis of the project is trying to solve some of the problems with cloud or vendor serverless, this kind of a locked-in platform that means that it's very restricted runtime environment. If you're an Amazon customer, you use AWS Lambda, you package your code in a zip file. If you have native dependencies like Sharp or something to resize images, you're really stuck. You have to download Amazon Linux in a VM, build DLLs against that, and it's just not pretty. Once you've got your function deployed though, you're probably okay, unless you have a mandate to go dual cloud or multi-cloud like one of our core contributors has had, and he works at a financial company in the UK. Then you have a whole different set of regions, a different zip file, a different API to upload the code, and a different version of that Node.js signature. So even if you're happy in one cloud, moving is kind of hard, but then when you try to move, if you're happy where you are, you might find that there's other limitations you come up against. I was in the Linka community call yesterday, and somebody asked, can I run Linka in Amazon Lambda? The answer is clearly not, because it's such a lockdown environment. So if there's tooling that you need, you just can't get to it. If there's extensions you want to add, if there's programming languages that are not supported, you kind of get stuck. Now, on the right-hand side of this picture, you see microservices and the enterprise. So one thing serverless doesn't do very well in the cloud is microservices. And also, what is a packaging and platform when you come to enterprise? Well, in this project, we believe that that's Kubernetes. Other platforms are supported with Docker images, but that allows you to run on any cloud you want, whether it's private or public or a mix of both. You can run any code, whether that's a template that we already have, a template from the template store, a pre-built function like the image transformations that Andrei's been putting together for us from Romania, or just some legacy C# or VB binary. It's all fair game. We can package it and run it in OpenFaaS, and then we can scale up dynamically, whether that's scaling the cluster, the pods, or even scaling to 0. And we think about this as serverless 2.0. Here's a quick reminder of what the function paradigm brings, because OpenFaaS supports both microservices and functions. So microservice, you tend to have your own Docker file for every service, your own entry point, your own TCP binding where you're doing a listen on a port, your own Kubernetes YAML. If you're using Prometheus, you've got to implement that separately in every language and kind of work around the intricacies of each package management system. And you end up potentially with 400 or 500 lines of code to achieve exactly the same as what we've got on the left. In OpenFaaS, can be as little as 2 lines of JavaScript code. You get exactly the same result. And you might think, well, I've only got one service, probably doesn't matter to you. But if you've got 100 like this, that deduplication is really, I think, really a productivity saver. So serverless 2.0, in order to have that portability, needed a runtime. That was part of what was holding it back before. and a packaging format better than a zip file. We believe that's the Docker image, and so do Google. The Knative project has also adopted this standard, and so any container that supports traffic on HTTP port 8080 can run in OpenFaaS, can run on Knative, and some of the other projects as well. So the landscape, as you see it, isn't a place where you just have to use OpenFaaS for everything, or Knative for everything, or Azure Functions. In fact, you can pick and mix the best parts that suit your workflow. And whilst I'd love you to use OpenFaaS for everything, you can use the OpenFaaS build templates and deploy them to Google's Cloud Run. You can use the Cloud Native build packs and deploy them to Knative or OpenFaaS. You can even use scale from zero from a different vendor. Now, obviously, we can help you the most if you use everything from OpenFaaS and then deploy that to Kubernetes or OpenShift, or maybe even OpenFaaS Cloud if you want an end-to-end experience. But this isn't a place where it all has to be from one project or tool. And that's the portability that you get that we didn't have before. So today we're going to talk a bit about Linkerd. I tweeted this out a couple of weeks ago as a bit of a tongue-in-cheek. Plonk, which is Prometheus for metrics, Linkerd for meshing and authentication, OpenFaaS for your compute and packaging, NATS for running asynchronously, and then Kubernetes to run on any cloud. So if you like the sound of that, you can ask me more about it later. You might already be using these tools together. If you want to install OpenFaaS and you don't have it yet, take a screenshot of this. This is literally all you have to type in. And we've been thinking about how to make that even easier with an install command. If you like the idea of an install command from the CLI, go and find the issue on GitHub and vote it up, or tell us how useful that would be for you. So we'll now move over to Vivek and Lucas, who are going to walk us through OpenFaaS logs.
Thanks, Alex. Hello, everyone. This is Vivek. So I'll share my screen. Can you all see my screen?
Yep.
Okay. So hi, everyone. This is Vivek. I'm from Bangalore, India, and I have been OpenFaaS contributor since last 2 years. So recently I wrote a blog regarding how you can get OpenFaaS functions log using OpenFaaS CLI. So previously you might have used something like kubectl or Docker CLI to get the functions log using container log. But we are happy to announce that you can get the functions log using OpenFaaS CLI itself, so you don't have to switch between different kind of CLI. So this support is available right now for Kubernetes provider, that is FastNatives, but we are adding support to other providers as well, and it's available starting from version 0.8.0. So, and also you need to upgrade the CLI version to 0.8.21 so that you get the functions log. So please make sure you upgrade your Kubernetes version and the CLI version. So for the purpose of this demo, I'll be creating a function called Astronaut Counter. Basically, it's a function which makes an API call to Notify API to get the number of astronauts that are there in International Space Station. So I mean, to save the time for this demo, I have already deployed the function and created the function. But I'll look through the function code and the stack.yaml file how it looks different. So I mean, this thing is pretty much same, but there are two flags that we have added, and these two flags, one is write debug, which basically writes different error messages and other more verbose logs on the OpenFaaS, and then there is something called combine output. So by default, combine output is false, and what it does is it combines the standard output and the standard error messages in the function response. But in order to separate the standard output and a standard error message, you need to set this flag so that your error message go to a standard error, and the output, a standard output message, goes to function response. And we have this function, which is very basic function, where we are just setting a logger and logging some statement, debug statement, and then making an API call and logging the how much time it took to make that API request. So yeah, so I have already deployed this function here. What we will do is we'll just invoke this function and try to get the logs using the FAS CLI. So so to get the logs, you have logs command available, and you type the function name, which is Astronaut Counter, and you can get the log. So let's invoke this function. And if you see, we are starting to get the logs here. So I'll invoke it multiple times. So what basically CLI does by default is when you type a FAS CLI logs and the function name, it tries to get the log and keeps the connection open for 30 seconds and stream the logs from the function. So yeah, so it by default it streams the logs. But suppose if you want to disable the stream and just get the log, you can pass follow equal to false, and it will just print the logs. Also, there are a couple of flags available with this command, which you can use to just, like, if you want to get some logs in last 10 minutes, you can pass the duration and get the logs, and you can pass the timestamp as well. Or if you want to tell the log like last 10 lines, you can just do that using this command, something like this. So yeah, so this is all we have added for now in the OpenFaaS CLI. We are currently adding support for other providers as well, and there is a provider, Loki provider, that is created by Lucas, which he will talk about in the next few minutes. So
thanks for that, Vivek. And just to say that the Docker Swarm provider is supported now. Lucas finished that, and we got it released, I think it was yesterday, including on Raspberry Pi if you're using it there. So that's now available. Great.
Okay.
Well, if people have questions or have comments, just drop them in the chat, and if there's any questions, we'll try and get to them at the end.
Sure. Yeah. So I'll stop sharing my screen. I'll pass it to Lucas.
Thanks, Vivek. As was mentioned, I'm going to share my screen in a second. Now that we have logs, we have them in Swarm and Kubernetes, and both of those are just coming from those cluster provider APIs. But we don't want to limit it to only what's available inside of Kubernetes or inside of Swarm's API. And when we were at KubeCon in Barcelona, I guess 2-3 months ago, they introduced something called Grafana Loki. And if you've used Prometheus, you've probably seen Grafana. It looks something like this. You've probably seen a dashboard with all sorts of metrics in it. And they've decided that they want to take a stab at logs, and they're going to utilize or integrate well with Prometheus, which is amazing news for OpenFaaS because that's what we also use. And the consequence is that if you go through and actually run the install, you can run it in Docker, but they have a Helm chart for Kubernetes here. And then you go into your Grafana, now you have logs immediately from all of your functions. And it's not just your functions, of course, it's everything in your cluster. But it's as simple as just saying the query fast underscore function equals, in this case, I pre-deployed something called echo me. So this is pretty great because from a administrative point of view, it's really easy to jump in and kind of explore. But since we want to make this really easy for everyone to use, it's also available from, wait, where's my browser? As a plugin for OpenFaaS as well. And the whole log system is designed to be pluggable, just like the function provider. So by default, Swarm, Kubernetes both provide logs out of the box. But if you're using Loki, then you can also get your logs from Loki instead. And so I did that quickly. There it is. So I also provide a Helm chart for this Loki provider. And at the very end, when you install it, it gives you this command, which will help you reconfigure your OpenFaaS. When you do that, then in my case, logs echo me. These will be logs that are actually being powered from that Loki provider instead of Kubernetes. And the great thing about this is from a developer perspective, you don't need to worry about this. It's always the same interface. Just like with secrets, you use the CLI and you always have secrets in the same way, whether it's local or production or some other environment. So that's a brief introduction to Grafana's Loki and our current integration with that.
Did you invoke the function? While we're looking at it. If anyone's got any questions about any of this, you can paste them. You can put them into the chat in Slack. We'll get to them just after.
So these last two lines here, let's see if I hide that, are from that last invocation. One of the potential downsides of Loki at the moment is that they've really focused on collecting and providing the logs, but they don't have a proper tailing, like following yet. So while with Kubernetes or Swarm-based API, you'll get log following. Right now with the Loki powered, you'll just get the like a single request and it finishes. The plus side is that Loki does contain history. So as your functions scale up or down, they'll still have that history from those older functions, which the Kubernetes API or the Swarm API will, as the containers go away, those logs won't be available anymore. So the trade-off right now is you gain history but lose the ability to follow, which may be a worthwhile trade-off. And Loki is probably going to resolve that in the near future.
Yeah, well, I can see that Steve and Siam and Christian, they're all excited about this. Please go try it out. Let Lucas know what you think. Lucas, maybe you can drop a link to that later on into Slack and people can pick up from there.
Of course. Thanks.
Great. So we're now over to Matthias, and this is some of the work that I've been doing along with him around Linkerd2. We built out this whole guide that's available on GitHub, and it runs you through how to install the latest and greatest 2.4. Hopefully that will work with 2.5 as well. And it tells you some of the things that you can get from a service mesh, and we're now going to give you a quick demonstration of that. So Matthias, are you ready?
Yeah, let me share my screen.
Yep, please.
Can you see that?
Yep.
Okay, good. So I already have Linkerd pre-installed on a Kubernetes cluster. It doesn't take long, but I thought it would be best to be prepared before. Demos don't always go good. So what we're first going to look at is the dashboard. Linkerd has a very rich dashboard where you can get a lot of metrics. You can basically tap into the traffic that is going through your application. And for OpenFaaS, we can get individual metrics for each function. So let's go ahead and start that up. There we go. Here you can see that I've installed OpenFaaS with an Nginx Ingress operator. You can see that everything is meshed. We have the Nginx Ingress operator, the gateway, and a few functions that I have running right now. So what we're going to do is we're going to look at the metrics that come to a specific function, which I call Hugo block, blue and green. So if you look at here, you can choose which deployment or which function you want to look at. And then I make a few calls here. You'll see that the requests are coming in. You can see basically who is calling the function. And when you look at this, you can see that we are getting mutual TLS because we know the authority of the request. In fact, if you look a bit deeper into Grafana, which they also provide with a bunch of very good metrics, we're going to be able to look into more details of the traffic that the function is getting. So for example, let's open up the gateway.
This is awesome.
And here you can get all the requests per seconds. You can even have specific like TCP connection metrics. We have all the outbound deployments that the Hugo function is calling. For example, we have 3 Hugo functions deployed, and you can see the metrics on each one.
Do you have Hey installed?
No,
I do, yeah.
If you get time, maybe when you've done your bit, you could show Hey running against it.
Yeah, let's do that.
Is somebody talking in the background, or is someone in your Marie?
I'm not really sure how the metric was. To 100. Oh, right. Here we're probably gonna get a lot of traffic to these 3 functions, which I have free deployed because next we're gonna show the traffic splitting. But for now, let's see a few metrics, and then we get a bit more information on that. And if I can minimize that, oh, there we go. So here you can see that we're getting a bunch of requests. We have 5 requests per second for the blue deployment, around the same for the green one, and the same one for the plain. So with this, you can get a pretty decent overview of your deployments. And with the Linkerd dashboard, you can even look at specific requests and get some form of tracing. There's also something that I wasn't able to quite look at in depth, but you can get specific routes that you can create from a Swagger spec. OpenFaaS has Swagger documentation for the gateway. And if you use that YAML file, you can create a bunch of a service profile that we have all of the routes for the OpenFaaS gateway, and you can get individual metrics for each endpoint specific for the gateway, which is pretty good. And you can even create retries and timeouts for example, if we want to have retries and timeouts for all of the functions, we can create over the service profile for this in particular route and basically configure it for every function that we have. Now, I mentioned that there was some traffic splitting. Linkerd in the version 2.4 included a way of doing traffic split using the SMI interface.
I've included I've just sent you the image that we were working on.
I have it running here.
There's a new one that I just sent to you on
Okay.
Slack.
Sure.
If you download it, you can open it.
There we go.
So the top, you need to zoom in a bit. The top one is if there's no service mesh at all. And then the second one is what you just showed us with the Linkerd doing the hard lines, and the dashed line being where it looks like the traffic is going. And so it's all going through the Linkerd injected sidecar, the proxy, the Rust proxy, from each component.
And right now we're going to demo the 50-50 canary split. We're going to have three functions. The root function, which is a Hugo blog that has a black background. The blue function, which has a blue background, and the green one, which has, as you would expect, a green background. So here you can see I'm using the Ingress operator that Alex built and mentioned previously. So I'm pointing to a function that was built with a Hugo template, so you can get like static websites. And here you can see that we get redirected to the different functions. This is all using Linkerd and the traffic split spec, which is actually quite simple. You simply specify the CRD and then mention which services you're going to be pointing to. Right now we're pointing to these two functions, and we can do it like a 50-50% split. There's a lot more to look at in Linkerd. Their documentation is very rich, so if you want to get a bit more information, you can head over to their website and check it out. That was it for me.
Could you show us that again? Going when you hit the URL, we should see.
Oh yeah, sorry.
Splitting.
So if you head over to here to this URL, test.matiaspan.me, you can actually go. It's live.
Should we put it somewhere?
Yeah, let's put it in the chat.
.me, I think that's right. Yes.
So whenever you make a new request, this is going to go through Nginx. Nginx is going to talk to the gateway. The gateway is going to talk to Linkerd actually, and Linkerd is going to be in charge of deciding which function we're calling.
Can you pull up the image again, the diagram?
Yeah, sure.
Maybe you can just walk us through the last one.
Sure. So this one right here. So whenever we invoke the function, we're going to go first through Nginx.
We're not seeing.
Oh, sorry. Yeah, I was sharing only. There we go. So first we go through Nginx, which is also meshed. After that, we go to the OpenFaaS gateway, and the OpenFaaS gateway is going to call. So the numbers here are actually incorrect. It's going to be like 500 and 500, but doesn't matter. It's a 50-50 split. And it's going to call either the canary function 1 or 2. In our case, it's blue or green. And the root function is going to still be redirected.
Yeah, that's
between the three.
That's basically right. And you can see on the right-hand side, we've got the two Docker image versions. We've got the 1.0 version and 2.0, and we can deploy them separately. And then through the SMI definition, we can gradually move that across to 100% to the new version if that's what we want. The root function, I don't think is strictly necessary. We could probably just do this with the primary and canary.
Yeah, that's
but
true.
it's the way that I tested it out. And I think there might be other ways of doing this. Stefan Proden demoed yesterday his Flagger project, and that does a kind of progressive switch over by testing the endpoint, seeing what the traffic is like if it's all 200s. In this example, this is up to you to do manually, or maybe you tweak it over time. One of the things that Linkerd also does, in addition to the mutual TLS, is really nice load balancing. So I wonder, Matthias, if you can show the dashboard where we've got all of the pods that are meshed, the individual replicas.
So yeah, right now I actually have only one replicas, and since I got this on a public cluster, I limited to only one replica. So I'm going to scale more than that.
So you can't scale that?
I specified a hard limit of one replica. Yeah.
Okay.
In case somebody wanted to play around with it.
On all of them?
Yeah.
Okay. So one of the things I'm doing at the moment is running some traffic into that, and from my computer, and if you look at it, we've got the blue and green is roughly split 50-50 at the moment.
It seems I forgot to
Okay, so that
set
one's
the hard limit here.
that one's working, and what you should
Yeah.
see is of the replicas of those pods, if it was running through the blue and the green pod, is it will be splitting very evenly between all of the pods. And one of the things Linkerd can do is, if you're using something like gRPC, is it tends to be quite sticky as to where the connections go. And the way we developed OpenFaaS with Kubernetes is it can be quite sticky as well. So you might have 10 replicas of your function, but most of the traffic is going to maybe one if the client's using Keep Alive. Linkerd is able to sort of circuit break that and make sure that the traffic is well balanced between all of the replicas that you've got. And I know that was something that was important for Martin Deckhoff in some of the work he was doing. We can't show you that now because Matthias has blocked his to only one replica, so there's no auto scaling. But if we did scale up to 100 replicas, even if the client had asked for Keep Alive, that traffic would be split across them all. So I think there's a lot of value in deploying this. It's very lightweight, and I don't think we've really used any, we've really come across any big issues with this. The traffic split is really new, but adds a lot of value to something like OpenFaaS, and we didn't have to change anything.
And actually, that's quite amazing. Installing Linkerd into your cluster, you'll notice if you're monitoring the resource that your nodes are using, you're going to notice a very, very small increase. So all the control plane and the data plane are very lightweight, and you can even, well, I think that you can now run it on Raspberry Pi. I think there was support for ARM, so it'll be interesting to try it out.
Yeah, there's a PR that's open, but it's not merged yet. And if anyone wants to try it out with OpenFaaS on ARM, you can just pick up the instructions there. Let us know if it works for you. Okay, so we've got plenty of time. If anybody has any questions about this and wants to try it, go and find the repo. Let us know what you think. There's also a lab. Matthias, if you open the README file again. So scroll down a little bit. And it says, do you need a lab environment? So something I put together for the OpenFaaS workshop is, you can click on it if you want, is basically Visual Studio Code that runs in the browser, completely in the browser, and it comes with Kubernetes through K3s, OpenFaaS, and all the tools that you need, like kubectl and FastCLI, all pre-installed. And there's even a script to get this up on DigitalOcean, so you can go from having no lab environment at all to a completely working droplet in a couple of minutes. And then you can run the workshop, you can install Linkerd there, and you can even access the dashboard. So go and check this out. So thanks, Matthias. The next speaker is going to be Carlos. And as I said earlier, he's been porting over to Risc-V platform. And if you've ever worked with ARM or Raspberry Pi and you've been frustrated when things are missing, that's very much the world that Carlos has been living in for the last few months. He's going to every project, finding that there's another project that's dependent on that, gradually working his way along. And I would encourage you to go and see his work here, even if you're not thinking of using Risc. I think it's quite interesting to see the process and how he's been doing this. So have you got a demo for us?
Yes. Can you hear me?
Yes.
Oh, great. Let me just share my screen here. Let me know if you see it. Can you see my screen?
Yes, we can see.
Oh, great. So, hi everyone. My name is Carlos. I've been working, playing a lot with Risc-V. I'm a cloud architect at Red Hat, and this is like my side project. I've been playing a little bit with Risc-V and following the progress on it. Sorry to correct you, Alex, it's Risc-V. It's the 5th installment of the Risc architecture. Risc-V is an open architecture that's developed in the University of Berkeley, California. It's been being worked for a while, for around more than 6 years already, by some students and some big names like David Patterson, like the father of a lot of publications and books on computer architecture. And it's, as it said, it's an open ISA, an open architecture, like x86 or ARM are architectures. Risc-V is a new architecture, but what's great about it is that it's open. So anyone can look at the documents, anyone can implement a processor on it, but it's like it's not an open processor. It's an open architecture. So the implementations of processors based on Risc-V don't need to be open. There are a lot of current implementations, current cores, Risc-V cores that are open. The biggest and most known ones are from SiFive, a company that was branched out from Berkeley itself. They started doing synthesizing the processors on FPGAs that are like boards that you can create processors on it. And they already taped out, created physical processors, real processors on the Risc-V architecture. One of them is the most well-known is the SiFive Unleashed. It's like an SBC, a small board computer, that's a quad-core Risc-V processor, for 8 gigabytes of memory, 1 gigabit Ethernet, and an SD card, and it can run Linux on this board. So you can already start developing on it. Also, there is a lot of support for Linux kernel for Risc-V. Also, QEMU, the emulator virtual machine creator, can also spawn Risc-V VM. I can give you the link in the end where you can download a Risc-V VM for QEMU to run on your computer. It can be, I have both Fedora and Debian distributions. And my talk is about containers and how the state we are in. A lot of stuff in Risc-V is still not upstream yet. Like I said, Fedora and Debian for Risc-V are still not 100% upstream on the main branches, so they are not still first citizens on that. But you can find the packages and lots of support on their testing environments. I run Fedora on my Risc-V, and I'll do a demo later, and you can take a look at it. So can we have containers on Risc-V? Yes, this is a presentation we used in Zurich in last June. Palmer Dalbert from SiFive presented the state we are in the software, and he presented this slide where I put together a quick Docker image that runs echo. It's a small, it's a small web framework written in Go where I built a hello world and built the image in Risc-V. And it's been a lot of work recently to bring up to date all projects that needs requirements for Risc-V, like Docker, Go, and a lot of programming languages. Go is still not upstreamed yet. We are trying to make it work on 1.14. 1.13 is currently in beta, so we have a merge window frozen right now. We have a tracker page where I have a lot of links to follow up this stuff, but we are tracking Go in an issue in their own repo. There are a lot of things to still be done, like setting up a builder. I already have it. So and upstreaming Go will have a lot of stuff moving forward fast. So we can have like base images built and everything else. So here is like a quick build of an image for Echo using BuildKit. This is run in my own board, running Fedora. Unleashed is the name of the board. And also we can have OpenFaaS running on it. It's a pretty new project. I think Alex merged the patches this week. I've been working with him for a while, bringing this up to date. It was pretty easy to do, like updating x.sys and xnet libraries from Go mostly. We already upstreamed that. So from now is tracking and updating the images. and OpenFaaS can run on Risc-V already.
Yeah, just to clarify, what we haven't done is we've not released new server-side images or a new CLI image for the time being. We've just taken a few updates to components that we were already using, and that was enough for Carlos. So yeah, you have about 5 minutes if you...
Okay, do the demo, Yeah, the images will be, we'll try to work together as soon as the other requirements get merged, like Go and everything in the base images. So let me just leave this link on. Here, I have the OpenFaaS portal running on the SBC, and also a small command line. Oh, OpenFaaS images running. It's currently a Risc-V 64-bit running kernel 5.2, pretty cutting edge. So we can already do a small Figlet demo. This image already runs on the. I had to rebuild the most images because we don't have base images available for Risc-V right now. So I built some of them. They are pushed into my GitHub, my Docker Hub repository. I have a Debian one. I'm planning to do NoPine as soon as Muscle, the RC library, gets merged and available. But I've been building and pushing all the images into my own Docker Hub repository. In the link that I'll leave afterwards, I have all of this. So we have the images. I already built the Figlet one, where you can do some tests. Also the Markdown render already works. So we have it rendering to HTML. And also the QR code works as well. So already built. It builds the QR code for.
That's supposed to put the extension on for you. So if somebody wants to look at that.
Oh yeah, true. So
that was broken.
So what's important here is that we already have set the base for everything. The next steps are waiting for having some base images. Tony Stigi from Docker is already working, helping a lot to have this up to date. And we already have some issues too that would be great to be tackled. Also, Prometheus have been built to monitor and track the functions we have in the portal, the invocation counts, and Prometheus image was pushed like a couple minutes ago. I built Prometheus and Alert Manager. Also have the PRs for that.
So,
for people that want to contribute, oh, sorry, Alex.
So would you say this is the first serverless platform for Risc-V?
Oh yeah, absolutely. It's like we are all cutting edge here. Like practically nobody have done containers or serverless or anything like that on Risc-V before. So we are on the edge right now.
Post? Are you going to write a blog post sometime soon?
Yeah, I'm planning on writing something like consolidating. I already have some writing here, a pretty complete README on the Risc-V tracker. I will transform this into a blog post to have like better view and
so I guess not many people have these Risc boards yet, other than maybe Alibaba and yourself and a few other people. Is there another way that we can help you if you want to try something out on Risc?
Yeah, sure, absolutely. So these Risc-V boards are pretty hard to get by and also very expensive. I got like one on their developer programs. They were sold for like $1,000 each. So it's like pretty expensive for a Raspberry Pi caliber board. But we are talking cutting edge and everything very new right now. But I've set here in the Risc-V tracker, there is a section called Risc-V Virtual Machine, Pre-Built Go and Docker, where you can download a VM It's a link to a QEMU VM on that's built on Debian right now, and also there is a README for it that you can take a look. So you can just run a shell script and it will spawn the QEMU VM, and you can SSH into it and start developing everything or trying to build your own applications on Risc-V. It's practically, you can also download Go 113. It's still off-tree. It's a repo that will plan to be merged on the 114 probably, but it's off-tree. I have already a pre-built Go tarball available here, and also if you want to run Docker, I've set a tarball as well with Docker and all its prereqs, and a shell script to install and have it up to date. So it's practically downloading the QEMU VM, Docker and Go, and you can start building it. Most base languages like Python can already run on Risc-V. The Fedora and Debian distributions already have like Python, have Perl. Node.js is still not available. People couldn't build V8 for it yet.
This is great stuff. I think I want to give Andre his time to present, but is there anything you want to finish on? Anything what's next for you in this journey? Because it's more than OpenFaaS. I think you're doing work with Kubernetes and other projects as well.
Yes, exactly. So the target here is to have something, have Kubernetes or K3S running someday. The big rock in our shoe right now is Cgo. Our branch, our Go Cgo, our Go branch still don't have support for Cgo, and Cgo is required for some Kubernetes dependencies, and also the runtime that runs the containers, like runc, it still depends on Cgo. We are using an alternate container runtime that's called cron it's written in C. So Cgo is our main problem right now. We still haven't got to our way to make it work, but the objective is like we are tracking it all here in the page. I already have a session for Kubernetes. But where I try to identify most its requirements, and etcd already have a PR that I will submit, that I submitted. So etcd can already run on Risc-V. The PR have not been merged yet. I have to ping the guys, but Kubernetes still requires Cgo. So
and you're doing all of this in your free time.
Exactly. This is like my pet
Amazing.
Project that I've been playing for a while on my free time. While I'm not swamped with work.
Well, it seems like there's a lot of people that appreciate what you've done there and are really impressed with your work. Thank you for presenting that to us. Thank you so much. So let's go to our next speaker, our last speaker. And after Andre's spoken about power, I've just got a closing note for everybody. So Andre reached out to me a few weeks ago, and it turned out that he and some teams at IBM separately had been trying to port different parts of OpenFaaS to the Power platform. And what we're going to see today is where Andre's got to and how Power is relevant to him and his work and what it might mean for us and the project. So would you like to share your screen?
Yeah, I'll try to do it. So I hope you see it and hear me.
Yep.
Okay. So hi, guys. First of all, I would like to thank Carlos for great job. So it's awesome what you did, Carlos. So I did much less than you. So I just tried to port OpenFaaS on another architecture on PPC64LE. So, but first I will say at least some words about me. I am not a programmer, I'm not a developer. I'm already 24 years in IT operations, and I'm a classic system administrator. So I worked and saw almost every Unix system out in the world. X, Solaris, Linux, almost every distribution of Linux. And now I work at a big German bank as a solution architect. I started several months ago my own project, free time, trying to port software to IBM Power Platform. So it's powerdevops.com. And yeah, that's what I do in my free time. I'm not from IBM. So it was the first question Alex asked me. Are you from IBM? No, I'm not from IBM. So I'm a customer for IBM. So I also would like to say some words why I like the platform and why, from my point of view, it's the best platform. So as Carlos already told, there are a lot of different instruction set architectures. Power is one of them. So it's originally Risc architecture was first invented and made in the middle of 80s. And since that time, it is it works. It is real performant. It's one of the most reliable architectures in the world. And comparing to other CPUs, is very performant. So, but it's not only CPU. So because we mostly work with systems and not with CPUs. So not only high performance core, but they have also a very large amount of memory of these systems. And they have, so Power 9 was the first system which used PCI Gen 4 for connection to devices. So you have some well-balanced system with a lot of memory, a lot of CPUs, and with very good I/O. So that's why it is very widely used in enterprise market. So almost every bank, every insurance company, almost a lot of companies use this type of service and these architectures. Several years ago, IBM made a big move from my point of view. So they made Power architecture or instruction set architecture open. So they founded Open Power Foundation, and every member of Open Power Foundation can use the instruction set to build their own cores and to build their own systems. So as for now, there is not just IBM Power systems, but there is, for example, Raptor Power systems, and there are time boards for Power. Google makes their own systems with Power CPUs. And as you see, there are a lot of members in this Open Power Foundation, and everybody makes something with Power CPUs. And that's not everything. So because the world's fastest supercomputer is built on IBM Power architecture. So it was built 1 year ago, and it's still the most powerful supercomputer. So that's why it's, from my point of view, it's one of the best architectures, one of the best technical things out of there for using. So, and there are a lot of different systems, as I told. So from some small systems which I used to test and to port OpenFaaS, and small in this environment is 20 cores, 1 terabyte of memory. It is small system, and the biggest systems are up to 192 cores and up to 64 terabytes of memory. And you know, when I see a system starting with 1,536 threads, so it's 1,536 logical CPUs. So it's really amazing. It's awesome. So what? It's something that you never forget if you do it once.
That would be a really big OpenFaaS cloud.
So, and this
how much would those two computers cost, Andre?
I wouldn't say. I'm not an IBM seller, so I wouldn't.
I assume it's a significant amount of money.
But it's a significant amount of money.
Yeah.
Exactly.
Hey guys, just as an add-on, sorry Andre, but you can have like a Power 9 computer right now for around like 1.5K US dollars, like $1,500 from Blackbird. I'm not sponsored or anything like that, but they are one of the first to bring Power 9 to the masses. Like you can buy a computer called Blackbird from a company called Raptor.
Yeah, that's the one that has, it's much less powerful, isn't it? I think it has like 4 or 8 cores.
Yes, they have options up to 18 or 16 cores, but the base one is like 4 cores, and you can have for like $1,500. So
well, if anyone
pretty
fancies
affordable.
one of those, maybe you can drop a link in for us.
Yeah. Thank you, Carlos. I didn't know about this, but I saw, for example, 10 main boards without memory selling for $250. So it is possible to find some cheap things, but usually they cost a lot of money. So you're right, Alex. Yeah. So I seen OpenFaaS first in December 2018. Watched a YouTube video from Alex's presentation in Copenhagen, and tried first in January or February on just normal Intel hardware. I was impressed by OpenFaaS, so it's really very easy for me. I'm not a developer, so but as for me, it was easy to write some functions and to test and to see how it works. It's awesome. So, and I thought, okay, if I will have time, and I will try to port it to PowerPC, and let's see what it goes. So this month I had time to port it, and it was another awesome impression. So it took me just 2 or 3 days to port everything I need and to launch it on Kubernetes on IBM Power server. I ported to Watchdogs, Gateway, templates, FAS, Metis. So, and it was really easy, and it just works. Nothing special.
I heard you might have tried 1 or 2 other projects.
Sorry, Alex?
I think you said you looked at a couple of other serverless projects as well.
Yeah. So before I ported OpenFaaS, so I tried to install Knative, because so I use on my work I use IBM Cloud Private, so it's IBM distribution of Kubernetes, and IBM had a technology preview of Knative for IBM Cloud Private. So I tried to install it and to look what's the difference between 2 of them, but really OpenFaaS is much easier to install and to use from my point of view. So I didn't get much further with Knative. With OpenFaaS, it was just, okay, here's an instruction on GitHub, I do it, everything works, it's okay.
That's great to hear. And, you know, I mentioned Linkerd earlier in the talk, and Prometheus and some other tools from the CNCF landscape. That's what we're going for, and I think is one of the reasons why those tools work really well with what we're trying to do. So thanks for that. Well, you've got a couple of minutes if you've got something to show us, or a quick demo if you can log into your machine.
Yeah, I can log into machine, so oops. So it's small Kubernetes cluster, so it takes some time. I don't know why. So just with 2 nodes, one master node, one worker node, and both nodes are on PowerPC 64 little endian. So as you see, everything works. So it's OpenFaaS, which I built from the sources, from official sources. With just, I think I made 2 or 3 small modifications to use base images for PPC64LE and not for Intel architecture. Oh, oops. ASCII works too. So yeah. Lambda. So I have just two functions, three functions. So the only problem I have, so it's the same problem as with Risc-V. So you have to port almost every function to PowerPC, because usually functions are built with Intel-based images and not with PowerPC-based images. So you have to rebuild the image for PowerPC.
Yeah, what I would like to ask the community, while we've got a few people here that are used to multiple architectures, is this is something that's going to affect every project that works on Kubernetes. What can we do? What's the best tooling at the moment? Maybe we can all get together after the call or next week or on Slack and think about, what architectures do we want to support in OpenFaaS officially and unofficially? What architectures do we want to know that work, like Power? And how do we do that? Because you're porting server components, right? And you're also porting client components.
Yeah.
We're shipping binaries. And I think the license check that's part of the CI now has Linux, Mac OS, Raspberry Pi, 64-bit ARM, Risc, Power, and one other platform. And suddenly we're shipping 10 binaries that are 5 megs each. And suddenly that one 5 meg binary is now 50 megs that's going into GitHub on every build. So we need to kind of think about how we're going to manage this going forward and how much of this do we want.
And one of the suggestions I made, so it's one of my examples, I tried to build a multi-architecture image, multi-architecture function. So I built it on my Mac laptop and was able to deploy on Intel Kubernetes cluster and on PowerPC Kubernetes cluster. So,
yeah, what's nice is that most Kubernetes images are already built for many architectures, mostly Intel, ARM64, ARM32, I believe. PowerPC is also built in the same CI, and the manifest points to all these images. So it's pretty transparent to build a Kubernetes cluster for any of these architectures right now.
yeah, exactly. So.
And I'm paving the way for Risc-V to be next.
So we've run out of time. Thank you so much, Andrew, and I hope that you can give us a bit of a deeper dive in the next call. What I'm now going to show everybody is just the closing words. What does OpenFaaS offer, right, to any of us? Some of us are new, some of us have been here a while, and it's good to remember. It's an easy way to package anything. This works with Linux and Windows as functions. Any binary, the OpenFaaS CLI can be a function. A C binary that you use to create images or split up videos can be a function. Even a high-performance Node.js process can be a function. It's native to Kubernetes, so there's a Helm chart, CRDs, controllers, everything that you could hope for. We've got metrics, observability, and logs, and you saw some of that today and how that's progressed. Queuing, going back to Plonk, that comes from the NAT section, but there's a well-known streaming company in Silicon Valley that's using OpenFaaS on their container orchestrator at the moment, and they're looking to see if they can swap that out for SQS. We've got auto-scaling, many different event triggers, and that is an SDK behind it. If you want to add ActiveMQ or whatever it is, you can use that SDK to build your own event trigger. Mutual TLS, thanks to Linka, AuthZ through some of the OIDC work that I've been doing in OpenFaaS Limited, and then traffic splitting. But beyond all of that, I think that one of the best parts of OpenFaaS is this community that we've got together today, and almost everybody that started the call has stayed on for an hour and 15 minutes. So thank you for that. And the rich ecosystem, right? We've got these different architectures, these different groups of people that all really are drawn to these qualities. If you have a function that you think is interesting, please submit it to the function store. If you've got a template that you think would be useful, maybe something in Scala or we're looking for one in Kotlin, please submit that to the template store and share it with everybody. So here's a few links. Take a screenshot, get a screen grab of this. If you're not in Slack, you can join on the top left. You can see where our roadmap's at with Trello. The second link, you can get my update. It's a bit more detailed, 2019 on YouTube. And then I'd love you to go ahead and just try OpenFaaS Cloud. This is a managed platform that you can install yourself or you can use as a SaaS. So thank you, everybody. It's been great to have you here.